Today we are going to present our project. Okay, the sustainable issues that we are stressing include municipality, air quality and other waste management due to flash floods that might have a negative influence on humans in order to develop a highway project. As a result, 4 SDG will be implemented in relation to the role of engineering in society, ethics and the professional obligation of an engineer to public safety, and the impact of engineering activities on economic, environmental, and sustainability. The SDGs chosen are climate action, good health and well-being, industry, innovation and infrastructure, and sustainable cities and communities. In our project proposal, we will provide sustainable highway infrastructure project indicators from the Malaysian Meteorological Department and Malaysia Highway Authorities MyGHI. We will plan a sustainable roadway infrastructure project, reduce floods, and manage municipal and other garbage in order to face heavy rain due to flash floods.
About our first innovation for this highway project, that is adding highway drainage system. Road and highway drainage is crucial for driver safety. A road highway drainage system is used in road and highway and other construction to control and avoid excess stagnant water on the surface and to remove rainwater from the carriageway as quickly as possible, so traffic can move more safely and efficiently. Poor highway drainage can handle heavy rain that can causing flash floods. So for this new highway project, it has a roadside slope drain. This invention should use sustainable road drainage solution. This environmentally friendly drainage system infiltrates as much as water as possible into the soil or into the river without exceeding prior river limitation. Next, we move to the Sustainable Development Goal that are related to this innovation. By adding highway drainage system, SDG 13 climate action is related to this innovation. This is because extreme weather events which are anticipated to increase in frequency and severity due to climate change might be reduced in damage with the help of well-planned highway drainage system. Flooding and other extreme weather conditions can harm transportation system and obstruct the flow of goods and services. Highway drainage systems are essential for preventing water damage to roads as well as preserving their stability and lifetime. In general, highway drainage systems are a crucial component of this infrastructure required to support the growth and development of resilient and sustainable communities, and SDG 13 can be achieved with the help of good management and design of this system.
Highway infrastructure innovation that our company choose to use in the highway is type of asphalt called open graded friction course. Modern asphalt technology and a modified bundle have been adopted by a majority of country because of the open aggregate structure ability to drain the surface water runoff more efficiently than concrete. So it can be reused. Asphalt pavement is a green technology that benefit the environment. All asphalt pavement is often recycled by being crushed and reused. Preamble salt is a new innovation that can help with a drainage by letting the water seep through the surface into the ground below. In contrast, concrete prevents water from seeping through the ground. It is widely agreed that asphalt is preferable compared to concrete for some paving jobs due to the former greater effectiveness. For this innovation, this highway is used for a type of asphalt that called open graded friction course. This asphalt can absorb 1,000 gallon of water per minute per square meter. As a result, the amount of water on the road will be minimized. They will no longer need to worry about flash flood due to this innovation because it can absorb the rainfall effectively.
Build an elevated highway such as flyover. In some cases, a flyover, also known as an overpass or an overbridge on the highway, may help to reduce the risk of flash flood by keeping the roadway above the level of the surrounding area. This can help prevent water from flowing onto the highway, reducing the risk of accidents and other disruptions caused by floods. Flyovers are also designed primarily to improve traffic flow. Building an elevated highway such as a flyover overpass to prevent flood could potentially contribute to the achievement of Sustainable Development Goal 3, SDG 3, which is focused on ensuring healthy lives and promoting well-being for all at all ages. An elevated highway may lower the risk of accidents and injuries caused by water on the road by contributing in the preventing of flooding. An elevated highway may also contribute to the safety and stability of the transportation system by lowering the risk of flood damage to the road, which can provide access to essential services and promote economic growth. However, it is crucial to take into account any potential negative effects of the project and to make sure that the elevated roadway is built and operated in a way to minimize any adverse effects on the environment and public health.
Next is roofed highway. The roof is one of the most significant components of a structure since it protects the inhabitants from rain, heat, and sunshine. To achieve building that is comfortable to occupy, the roof of a tropical structure must be created with the regional climate in mind. Building roofs along roadways can assist prevent rainfall from pouring into the road. The installation of sloping roofs will aid in the drainage of precipitation that falls into the highway. The water will enter the drainage system and go to the nearest river. Roof construction may be classified into two categories, which are flat roofs and steep roofs. The SDG 11 is concerned with making cities and human settlements more accessible, secure, resilient, and sustainable. A roofed motorway might help achieve this aim. The main advantage of Malaysia's roofed roadway is that it helps to make the city more robust. Smart urban infrastructures are one of the features of SDG 11, which is sustainable cities and communities that will expand it to combat climate change. The frequency and severity of major storms in Malaysia have grown as a result of climate change.
Move on to subcriteria of environmental and water management. Firstly, a roof highway that is planned and constructed with an environmental management system in mind can help preventing flash floods. For instance, an EMS can mandate that the roadway be planned and built in a way that has the least possible negative effects on the local ecosystems and natural resources. This may entail taking steps to safeguard and preserve natural ecosystems, reduce the amount of land disturbed during development, and incorporate features that aid in stormwater runoff management. A roof highway can help accomplish SDG 11 and other related goals by using these concepts to its planning, construction, and operation, making cities and human settlements inclusive, safe, resilient, and sustainable will enable them to be connected to environmental management systems according to SDG 11.
Next, we move to the second subcriteria of environmental and water management, that is stormwater runoff quantity. SDG 13 climate action is related to stormwater discharge in several ways. Urban stormwater management can affect local water bodies and the environment health. Flooding, water contamination, and habitat loss can result from poorly managed stormwater. Highway drainage system can help control stormwater. They collect and transmit road and area rainwater runoff to prevent flooding. Stormwater runoff from roadways can convey heavy metals, oil, and trash to surrounding aquatic bodies. Oil water separators, filtration system, and sediment ponds are used to prevent this. Properly planned and maintained highway drainage system can reduce stormwater runoff and support SDG 13. Considering the entire life cycle of highway drainage system from construction to maintenance to decommissioning and can assist minimize environmental impact and contribute to SDG 13.
Stormwater runoff quality. Elevated roadways are an example of a stormwater runoff control measure that can help reduce the impacts of flooding on communities. These roads are built above ground and they are supported above the ground by a series of columns or piles. When a storm occurs and the water level rises, the roadway remains above the water level, allowing vehicles to continue using it. Since they allow the road to stay open and usable even during a flood event, elevated roadways can be a useful solution for areas that are prone to flooding. This may reduce the risk of accidents and injuries as well as the financial toll that flooding has on the community. Additionally, elevated roadways can help achieve Sustainable Development Goal 3 (SDG 3), which is to ensure everyone has access to healthy lives and promote well-being. Elevated roadways can reduce the negative effects of flooding on communities and change the general health and well-being of affected areas by aiding in flood prevention. During construction and maintenance, elevated roads can also provide employment and economic opportunities, improving the local community health and quality of life.
Ecosystem protection and preservation. The Sustainable Development Goal call for the creation of resilient infrastructure, including transportation and communication system that can withstand the effect of climate change and other environmental challenges. Open-graded friction cost asphalt can help achieve SDG number 9, which call for the development of resilient infrastructure. We can contribute to the construction of infrastructure that more resistant to the effect of natural disaster and other environmental issue by encouraging the use of open-graded friction cost asphalt, which is more resistant to erosion, flooding than other form of pavement. This can then support the overreaching objective of sustainable development by protecting and preserving ecosystem. In general, there are numerous ways that using open-graded friction cost asphalt might help accomplish SDG 9. We can aid in the preservation of ecosystem and advance the general objective of sustainable development by encouraging the construction of resilient infrastructure that can survive the effect of climate change and other environmental problems.
Our conclusion is, in order to decreasing the risk of flash floods in Malaysia, some sustainable highway innovations applied and be implemented in this project. 4 new ideas have been used in this project to solve the problem of flash floods on the highway. This highway should have better drainage, open-graded friction costs as the road material, elevated highway and roof highway contributes to the reduction of the risk of flash floods. 4 sub-criteria of environment and water management (EWM) have been discussed and developed in this project. Environmental management system, stormwater runoff quantity, stormwater runoff quality, and ecosystem protection and preservation have been identified as sub-criteria. To put it simply, engineers have a responsibility to society to use their knowledge and experience to better people's lives and communities while maintaining the highest ethical and professional standards. Thank you.